for this problem, this is 3 times x times y times y times y times y, right? That's 5 y's. And all of that is happening 3 times. Now look, like I'm kind of lazy. I'm going to write these out. But in the future, like my strategy is I just like write the parentheses and then I don't actually write it, right? Just to be kind of lazy. But for this first one, let's write it out so we can really see it. 3 times 3 times 3. That's 27. X times x times x. That's x to the third. This is y times y times y. I'm not going to say all of them. Look, there's 5 y's. And then times 5 more y's times 5 more y's. How many total y's are there? Y to the power of 15. Okay? Now listen, you wrote it out this time. Ideally, you don't have to write it out every time, right? Observe the pattern. This was 3 to the power of 3. It was x to the power of 3. And then this y to the fifth to the power of 3. It was 5 y's 3 times, right? This was 1x 3 times. This was 3 multiplied by itself 3 times. All right? Let's go over here. Okay, so the first thing I observe is that there's a negative exponent here. So what I like to do is just take like a whole step to just move the negative exponent. Otherwise, I end up kind of getting mixed up. So I'm just going to take, only thing I'm doing in this step is just moving this to the top. Okay, and then, okay, I'm taking this, and now I'm going to simplify. First, I'm going to simplify this, the a's, right? Now think about what this is. This is 3 a's on top and 5 a's on the bottom. So when these cancel, I'm left with just 2 a's on the bottom. So over here, look, I still have the 9 on top, I still have the 7 on the bottom, and I'm left with 2 a's on the bottom. Okay, and for the next time, if you don't have to write it out, you can say, okay, I have 3 a's on top, 5 on the bottom. So when I cancel 3, I'm going to run out of canceling options on the top, but I'm still going to have 2 left over on the bottom. My b's are on the top, right? I have 2 b's. This is b times another 3 b's. So that's a total of 5 b's on the top. And now I'm going to take this and square it. Okay, and look here, watch, I'm not going to write it out, but I'm going to, oh, sorry. I'm not going to write it out like I did on the first one, but I'm going to think about it, right? So in my head, I'm thinking, okay, this is going to be, look, like I'm squaring it. So there's like an invisible 9 here, 9 times 9, okay, that's 81. This is b times b times b times 5 b's, and another 5 b's, that's a total of 10 b's. This is 7 times 7, that's 49. And this is a times another a times a, that's a to the 4th. Okay, looks like that. Okay, here I have n to the negative 7th. What that means is that this is unhappy. Oh, it's so negative, right? It's because it's on the wrong side of this invisible fraction, right? So this n is unhappy on the top, and it wants to be on the bottom, and so that's where we're going to move it, and then there's nothing on the top, so we just use this placeholder of 1, and I'm done. Okay, here, look, let's like pretend we're using this strategy of writing it out, but let's not. Okay, so look, I'm going to pretend that this is written out 2 times x and 3 times n times n times n. I'm going to pretend it's written out 4 times. Okay, so that's 2 times 2 times 2 times 2. That's 2 to the 4th, that's 16. That's x times 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 x. That's 2 x's 4 times. That's a total of 8 x's. This is 3 times 3 times 3 times 3. That's 3 to the 4th. And this is 5 n's, and then another 5 n's, and another 5 n's, and another 5 n's. So that's 5 n's 4 times. Okay, next one. This is like just the classic, right? This is 3 x's times 5 more x's. That's a total of 8 x's. Okay, this one, right? And ideally, like I'm writing it out because I want you to like write it out in your head, right? Like, I don't want you to have to write these out forever. But like in my head, this is what I see. This is what I imagine. Oh, I'm crossing off 2. What do I have left? I have 6 m's left, right? They're on top, so I can just write it without a fraction. Let's say I had the 6 m's on the bottom. Like, let's say it was like this. Then I would have the 6 m's on the bottom like this, right? Just like a little side note, okay? All right, for this one, I observe that this part is unhappy. We don't like our variables to be unhappy. Let's go ahead and move it. The only thing I'm doing in this step is just moving that y. And then I'm going to go ahead and keep simplifying. So I notice here I have 4 x's on top and 1 on the bottom, so those cancel. So that 5 is going to stay right there. I'm left with 3 x's on the top. And then there's 5 y's and 2 more y's on the bottom, so that's y to the 7th. That one's done. Okay, this is 4 x's, right, times another 4 x's, times another 4 x's. That's x to the 12th. And last problem, First thing I notice, oh, is this unhappy b, so let's move it down to the bottom of this invisible fraction where it can be happier. And now to the power of 3, and that now it's like very much like this problem, right, where we're just, you know, doing everything 3 times, right? So that's 5 times 5 times 5, and that's 4 a's 3 times, like pretty much like what we just did here, right? This was 4 x's 3 times, this is going to be 4 a's 3 times, same deal. And this is 3 b's 3 times. Oh, 3 b's 3 times, right? That's b to the 9th, right? That's this 3 times, all right? There it is. Okay, and now here, when we convert to exponent form, remember what we need to know is that this is called the index, right? Let's say this is an x. This is called the exponent. And when we write it like this with a fraction, the fraction is exponent over index. That's all you need to know, all right? So here, the exponent is an invisible 1, right? So that's the exponent over, and the index is 6. Here, the exponent is an invisible 1, and the index, so remember when the exponent's not written, it's 1, and when the index is not written, it's an invisible 2. So this is x to the power of 1, exponent over index, 1 over 2. This is w to the power of exponent over index, 5 over 3. This is a to the power of exponent over index. This is 8 over, oh, there's no index written, that's a 2. And ooh, we don't leave 8 over 2. That can be simplified. That's a to the power of 4. Okay, now let's go the other direction. Okay, so now we're going from this to this. So when I make my radical sign, I'm going to put my x. So this becomes the exponent. Oh, I don't write that. It's invisible, right? And then this becomes the index. Oh, I don't write that. It's invisible. Done. Okay, here. This becomes the exponent. This becomes the index. Okay, here. This becomes the exponent. This becomes the index. Oh, I don't write a 2 as an index, right? It's invisible. And then last one. This becomes the exponent. Oh, that one's invisible, right? We don't write 1s as exponents. Okay, and then the 5 is the index. Okay, let me just write that a little bit neater. Okay, so here. Okay, no exponent. All right, that's it.